Welcome, this is Peter Nicholas, and in this session, mathematics lesson, we want to look at velocity time graph. This as a topic in a topic that is called linear motion. If you look at my previous clips, I discussed some concept in linear motion, and that is relative speed. So in this one now, we want to look at velocity time graph. And before we look at that, there are some concepts that we need to remind ourselves. And number one is displacement, and how it is related to and the distance. And then that's number one. Number two is velocity and speed. And number three is acceleration. Okay, acceleration. So what do we mean by displacement? So displacement is a distance. It's changing distance. I mean, displacement is just distance with a direction. Okay. So this is the same as distance, but with direction. So this is said to be a vector. It is a vector, while this one is said to be scalar. So the only difference between displacement and distance, I understand you know what we mean by distance. The difference is that this one has both magnitude and direction, while this one has only magnitude. What we mean by magnitude is the size of the distance, maybe 10 kilometers or 20 meters. So that is the magnitude. But now the displacement now will tell us the direction. Maybe 10 meters to the north or 10 meters upwards and so on. Well, this one will only tell us the size of the distance covered. And velocity and speed, speed we know is the change in distance over time. So speed is change in distance over time. Over change in time, you can say over time. Okay? While now velocity is change in displacement over time. Okay? So this is the ratio of displacement with time, and this one is the ratio of what? Distance with time. And by now you know the difference between distance and displacement. They mean the same thing, only that this one will give us more direction. I mean more information concerning the direction of the movement or of the distance. So now the difference between speed and velocity is that this one gives more information about the direction of the speed. Okay, so you can say that velocity is speed with direction. Okay, so that is the difference. Velocity is the speed with the direction. For example, you can say 10 meters per second upwards. So this one now is the magnitude. This is the magnitude or the size of the speed. When this is the direction. Upwards, downwards, eastwards, westwards, and so on. So the people normally confuse or use velocity in places of speed, or they use interchangeably, which is okay. The only difference is the direction. This one will tell more about, when you are referring to velocity, you must talk about what? About the direction. Acceleration now is the change in velocity or speed with time. So acceleration is change in velocity with time. Okay? Acceleration is change in velocity with time. We know that when you are covering some distance, you may not cover with the same, displacement you may not cover with the same velocity. Sometimes you will be slow, other times you are fast. So that change in velocity over time is called acceleration. So acceleration also shows the shows the direction. Okay, so acceleration shows the direction. So this is change in velocity over change in time. If it is upward, then the acceleration is positive. It's normally taken to be positive. But if it is downward, the acceleration is taken to be negative, which is also referred to retardation. Retardation or deceleration. Deceleration. So this is a negative. This is a negative acceleration. This is a negative acceleration. So it is called retardation or deceleration. Now, having reminded ourselves these terms, I think now we can now discuss what we mean by velocity time graph. Okay, so velocity time graph is normally plotted by plotting the units of velocity in meters per second mostly against what? Against time. And time in this case is seconds. Okay, so you draw your Cartesian plane and then you plot the points of velocity on the y-axis or vertical axis, and then time in the what? Horizontal axis. Okay, so this shows that the time is increasing, and this one shows that the velocity is increasing from the origin, which is 0. So we can give an example. For example, you may be told that a body moves gradually from 0 to a velocity of 15. So it moves gradually from 0 to a velocity of 15 meters per second. With what time? Let us say we can use 10 seconds. Okay? So the body moved gradually from velocity of 0 to 15 with what time? 10 seconds, within 10 seconds. Okay? And then now it moved with the same velocity of 15. It moved with the same velocity of 15, meaning that the velocity now will be constant. Okay, so we'll have a horizontal line because the velocity is neither increasing or decreasing like that. For we can say how many minutes? Seconds. Let us say for 30 seconds. For 20 seconds, so that when you add with this 10, you get 30. So from here to here, we have what? 20 seconds. Then from here to here, the change in time is 10 seconds. Okay? So the body moved with the same velocity of 15 meters per second for how many seconds? For 20 seconds. From there, it decreased, the velocity decreased gradually or uniformly from 15 to 0. Okay? It decreased gradually from 15 to 0. For how many seconds? Let us say this is another 20 seconds. So 20 plus 30 will be 50 seconds. So it moved gradually from 15 to 0. So that now the diagram we will have is something like a trapezium. So from 0 to this point here, the velocity is increasing, the speed is increasing from 0 to 15. And then from this point here, it is horizontal, meaning that the velocity is constant, 15, up to this point. From what? And then from 15 now it reduced to 0. And the change in time is that from here to this point is 10 seconds, from here to here is 20 seconds, and then from here to here we have another 20 seconds. But what we are writing here, that is 10, 30, and 50, is now the accumulation of time. Because here we have from here to this point 10, and then you add another 20, which is 30, then you add 20 to get 50. So in this diagram now, we can obtain what we have here is velocity and time, but we can get what? We can get acceleration, and also we can get
distance. Distance or displacement. Distance or displacement. Okay, we can get distance here because we don't have to show the direction. Okay? But now, so how do we get acceleration? How do we get acceleration? We get acceleration by getting the gradient of this line, because we know that acceleration is equal to change in velocity all over change in time. The change in velocity over change in time. How can we get that? For example, our initial velocity here, starting velocity is 0 meters per second. So initial velocity is equal to 0 meters per second, and then final velocity is what? This mark here, which is 15 meters per second. Okay? And what is the change in time? From 0 to 10 seconds. So to get acceleration we say initial velocity, which you can denote by, so initial velocity you can denote it by u, and then final we denote it by v. So to get acceleration, we will say v minus u all over time. Okay, so our v is 15 minus 0 all over change in time. Change in time is 10 minus 0, which is 10. Okay, so this now will give us 15 all over 10. And now that will give us 1.5 meters per second square, because that is the unit of acceleration. So the acceleration there is 1.5 meters per second. So that is the change, the average change in velocity. In this case here, let us get, so our acceleration here is 1.5 meters per second square. What about the acceleration here? What is the acceleration? Acceleration, we are taking this to be our u. Okay? And then this is v. So to get acceleration, we will say this is 15, because it has not changed, minus our u is also 15, divided by change in time, which is 30 minus 10, which is 20. Okay? So this will give us 0 all over 20, which is 0. Okay? So acceleration here is 0, because the speed is, or the velocity is not changing, it remains constant. And then now going downwards, because you are saying that it is reducing from maximum to 0, how do we get the acceleration there? This now will be our u, and this is v. Okay? So our v is 0 meters per second, and our u is 15 meters per second. And now to get acceleration there, acceleration will be v minus u all over t. So v is 0. So 0 minus u, which is 15, divided by time, which is 20. That is the change in time. So this will give us negative 15 all over 20, which now when you divide you get what? When you divide you get by 2, 10 by 2, negative 7.5, you get negative 0.75 meters per second squared. Okay? So this now will give us negative 0.75 meters per second squared. But you can see that it is negative. It is negative because it is decreasing. The speed is decreasing. I mean the acceleration is decreasing. This one it was increasing. That's why it is positive. So acceleration here is negative 0.75. So when you are asked to calculate and this is called deceleration. We say that negative acceleration is called retardation or deceleration. So that is how we can get acceleration from the velocity time graph. You just look for the gradient of the lines. What about the next thing that we can look at is the distance. Okay, distance, which is also said to be displacement, and because we are not considering the direction here, then we can just say that it is what? Distance. So how do we get distance? Okay, Okay, so how do we get distance? How do we get distance? So distance is normally said to be speed times time. Speed times time. We know that speed is in meters over seconds and time is in seconds. In seconds. So by this one, and this will give us meters. However, distance, when you multiply speed by time, you will get distance, which is normally given by in meters. Okay? So how do we get the distance here? So when you find the area of this graph, you find the area under this graph, this area. Okay? When you get the area under this graph, this is a trapezium. Okay? This is a trapezium. And we know that the area of trapezium is given by a half a plus b multiplied by height, where a and b are the pair of parallel sides, and height is the perpendicular. The perpendicular height from the two distance from the two parallel sides. Here, and in this case, when you are considering these parallel lines, this one here, this and this shows the time. Okay, the time. Okay, like for example, this height here, this length here is what? Is equivalent to 50 seconds. 50 minus 0, which is 50 seconds. We can say this is we can say this is A and this is B. Okay, a pair of parallel lines. And what is the length of this side? It is 30 minus 10, which is 20. And this is 50. This is 50. Okay? What about our perpendicular height? Our perpendicular height, which is just equal to this, is given by velocity. It is given by velocity because it is vertical displacement, which is represented by velocity. This one is horizontal displacement, which is represented by time. Okay, so to get now the distance, to get now the area of this, the area of the region under the graph is the same as a half multiplied by a, which is 20 seconds, plus b, which is 50 seconds, multiplied by height, which is what? Which is 15 meters per second. 15 meters per second. Okay? So if you simplify this, you get a half multiplied by 70 seconds multiplied by 15 meters per second. So this second will go with this, this one by this 35. And if now you multiply, you'll find that the unit is in meters. Okay? So this will give us 35 times 15. 2, 15, 17, 5, 3, which is 5, 2, 5. Okay, so we will get 525 meters. Okay, and what is given in meters? It is distance. That now will make us to believe that to get the distance covered by that body, you just calculate the area under the graph. Okay, so the distance in a velocity time graph is obtained by getting the area under the graph. So that is the conclusion that we can make. We can say that acceleration is given by the gradient of the lines of the line, while distance is given by the area under the graph. The area under the graph. So that is in a velocity time graph. Acceleration is given by the gradient, okay, the line, and distance is given by the area under graph. So that is what you need to understand for you to be able to obtain maximum marks as far as velocity time graph is concerned. So now what we want to do is that we are going to do a question. We're going to do a question together, which is that carries 10 marks concerning velocity time graph. So let me write a question down.
Okay, so this is the question. The diagram below shows the speed time graph for a lorry traveling between two stations. The lorry starts from right and accelerates uniformly. Accelerates uniformly for 150 seconds. I mean, lorry starts from rest and accelerates uniformly for 150 seconds. It then travels at a constant speed for 300 seconds and finally decelerates uniformly for 200 seconds. The distance between the two stations is 10,450 meters. So let us look at our graph here. So we have the speed in meters per second, and here we have horizontal axis. We have time in seconds, and you are told that the speed or the vehicle accelerates uniformly, or the speed increases gradually from zero for 150 seconds. So we do not have this speed here. Okay. So we do not have the maximum velocity that the vehicle attained. We are just told that it accelerated or it increased gradually for 150 seconds to this point, and then now it then travels at a constant speed. So this one here, the horizontal, you remember that the horizontal shows that the speed is not increasing nor decreasing. Horizontal speed for how many seconds? For 300 seconds. That is for 50 minus 150, you get 300 seconds. So this is 300 seconds, this is 150 seconds, and the speed is uniform. Then again, you're told from this point now, it decelerated, or the speed gradually decreased from the maximum, because the height is the same, to 0. Okay? So this there is a deceleration here. This is deceleration. This one is acceleration, and in this case here, acceleration is 0 because the speed is not changing. And what is the time taken here? The time is 650 minus 450, which will give us 200. So this is 200 seconds. Okay, so that is basically some information that we can obtain from the diagram. And now we want to do the question. Question number A. Question A, let us calculate the maximum speed in meters per second attained by the lorry. That is 2 marks. You are told you calculate the maximum speed in meters per second attained by the lorry. So how do you get the speed? Okay, the maximum speed here is given by the maximum height, or given by the maximum height of the graph. What you can see here is the trapezium. The shape of this graph is a trapezium, and the height now will indicate the maximum height will indicate the maximum speed, because we know that the vertical axis shows the changes in speed. Therefore, our maximum height now, this here will indicate the maximum speed. Okay? So how do we get this maximum speed? What we can do is that we know the total distance. We are given the total distance of the distance is 10 for 50 meters. And we say that to get the distance in a velocity or speed time graph, you get the area under the graph. And the area of this graph is in the shape of trapezium. So we can get the area because we have the pair of parallel sides, and now we can get the vertical height, which will give us the maximum speed. So we know that the area of a trapezium is given by a half a plus b multiplied by height. Okay, so our area is 10 for 50 is equal to a half multiplied by, into bracket a here, okay, a, which is now the change in time.
not acceleration, but it is 450 minus 150, which is 200. Okay, so it is 200 plus, because we know that these horizontal lines are indicated by time. So from here, which is 450, to this point here, 150. So to get this, the length of this line in terms of time, it is 450 minus 150, which is 200. So this is 200. And now to get this one here, this horizontal line, it is 650 minus 0, which now will give us 650. So this is 650. Okay? And then now you multiply by height, which we do not have. Okay? So what we do here is that we will simplify this. So it will be 10 for 50 is equal to a half multiplied by, this is the same as 850 h. Okay, so by 2, 1 by 2, 425. Therefore, so it is 425 h is equal to 10 for 50. And then now you divide by 425, you divide by 425. And now that will give us, you may take the subject. So if you say 425, I mean 10 for 50 divided by 425. Okay, there is an error that we made here. This is supposed to be 300, not 200. This is 300 because it is 450 minus 150. So if you look at 450 minus 150, you get 300. So 300 plus sorry for that slight mistake. So that will be a half multiplied by 300 plus 650, you get 950. 950 multiplied by height. So if you divide this, you get 475. So it will be 10 for 50 is equal to 475 h. You divide by 475, you divide by 475. This will go with this, we are left with h. Then now it is 10 for 50 divided by 475. This will give us 22 meters per second. 22 meters per second, because it is multiplication of seconds by what? I mean, you are dividing distances in meters. You divide, this is in meters and this is in second. So if you divide, you get meters per second. So that is our maximum, that is the height, which now we give, which is our maximum velocity. So our maximum velocity here will be 22 meters per second. So that is the maximum displacement, vertical displacement. Number 2, question number 2. So that's how we do that. To get number 2, the question is asking acceleration. B, calculate acceleration. Calculate the acceleration. Acceleration, we say that is the change in speed over change in time. And the part of the graph that is showing acceleration is this part. Because this acceleration is 0, this one it is deceleration. Okay? And acceleration is negative. So the only part that is showing acceleration or increase in speed with time is this part here. And we say that to get acceleration is final velocity, which is v, minus initial velocity divided by change in time. Okay? Change in time. So our final velocity here is 22 meters per second. This is 22 meters per second. And our initial velocity is 0. Okay? So it will be 22 minus 0 divided by, change in time is 150 minus 0. So that will just give us 150. So this will be 22 divided by 150, which will be 22 divided by 150. 20 divided by 150 will give us 0.14467 meters per second square. So that is the units of acceleration. Meters per second square. So that is the acceleration. That is the acceleration. The next question is. The next question we are going to. I can write it here. Number C. Number C, you're told the distance. During the last 100 seconds. So this is 3 marks. This was 2 marks. You're told to calculate the distance the lorry traveled during the last 100 seconds. The last 100 seconds is the midpoint of this. You can say that because you know from here to here is 200, therefore it will be something like this. So this will be the last 100 seconds from this point here. That is the last 100 seconds, and we know that the height or the velocity is that at that point. So that is our height. So to get the distance travel within the last 100 seconds is the area under that triangle. The area under that triangle. So how can we get the area of this triangle? And we do not know the height. We do not know the height here. We don't know the height or the velocity. And the only thing that we know is the time. But also, because this is a straight line, and we know that the gradient is on a straight line is uniform. And in this topic or in this concept, gradient is represented by acceleration or deceleration. So we can get the deceleration here. We can get the acceleration or deceleration, and then which is uniform for the entire line. And now, if we get that, then we can use to calculate the area under the area under the graph, under this part of the graph. So how do we get the acceleration? We can get acceleration because we can take that, and this part of this line here, our u is that. Our u is 22. That is the beginning. Okay, that is the initial velocity, and the final velocity is rest, which is 0. Okay, so we can get it by saying that acceleration, we know that is u. Is v divided by u over time. So our v is this 0. So it is 0 minus 22 divided by time, which is 650 minus 450, because we want to know the gradient of this line. 650 minus 450, you get 200. So 200. So this will be negative 22 all over 200. Negative 22 over 200 by this 100 by this negative 11. So that will give us negative 0.11 meters per second square. Okay? So that is the acceleration. That is the deceleration because it is negative, and it is shown by the gradient, or it represents the gradient of this line. And because we know that the gradient of a straight line is uniform for every 2 points, we know that we can take this acceleration here to be negative 0.11, and now we try to calculate it here. So we can say that this is our u and our v is that, so that we get maximum velocity here, which is represented by our height. So we will say that 0 minus u divided by time, which is 100, is equal to negative 0.11. Okay, so that will be negative u divided by 100 is equal to negative 0.11. You multiply by 100, you multiply by 100. So that negative u is equal to negative 11. you divide by negative, you divide by negative, you get u is equal to 11. Okay? Or negative 1, you divide by negative 1, you divide by negative 1. You get u is 11. And our u is represented by this displacement, which is height. So you can say that our height here is 11. Okay? So this is 11 meters per second. So now that we have the height of the triangle, which is 11, and the base, which is 100, and this is a right angle triangle, we can get the area. So now we will just say that the area of a triangle is a half base times height, which is a half times base, which is 100 seconds, times height, which is 11 meters per second. So this will go with that, by this one, by this 50. If you multiply, you get the area now will be 550 meters. So this is the distance covered within the last 100 seconds. It is 550 meters. So that is how you do it. You can get the acceleration because it is not correct unless you use similarity to assume that this is 11. So the surest way is that you calculate the gradient of this line, and because you know that it is uniform, then you can take this point to be your initial velocity and this to be final, and now you try to look for that deceleration, and that will give you the maximum, the height here, which now will be the height of the triangle, and this is the base of the triangle. You calculate the area, and that area now will give you the distance covered by the lorry within those 100 seconds. Okay, so I believe you have understood. Now lastly, B. B, you are told calculate the time the lorry takes to travel first half of the journey. Calculate and that is 3 marks. Calculate the time the lorry takes to travel first half of the journey. So it's like we are dividing this journey of ours into two, and to know the half of a journey is you normally consider the distance. Okay, so we know the distance of this journey. The distance of this journey was so total distance of the journey. Total distance is 10 for 50 meters. Okay, so a half of the journey now will be a half of 10 for 50, which now will give us 5 to 25 meters. So this is a half of the journey. And how is this represented in the diagram? So we can just take any line here to divide like that. Okay, so now this will be the last half of the journey, and this is the first half of the journey. And there are some things that we don't know here. The only thing that we know is the maximum height. So we know the maximum height of this, because now this will be the first half of the journey. The area of this graph here, a trapezium, which is like this. So it's a trapezium like that. Okay, so we know that this is 22, or the height is 22. The height is 22, and also we know that from this point to this is 150. From this point here to this is 150, but we do not know this extension, so you can make it to be x. And this extension now is just the same as this. My diagram may not show it clearly, but we can see here that the distance is just the same as this. So because we know that from this point to this one here is 150, so we can make this to be x, and also this one will be x. Okay, so now having this now, and we know that the area is 5225. So to get the distance, you find the area of this graph here, which is this shape. So it will be, area will be equal to a half multiplied by, because it's a trapezium, so it is x, because our A is x, plus this one here is 150 plus x, 150 plus x, and then now we multiply by height, which is 22, and that will give us, and now that area is 5225, because the area is represented by the distance. Okay, by this one, by this 11, and now it will be 5225 is equal to, this will be 2x plus 150 by 11. You divide this side by 11, you divide this side by 11. This will go with this. 5225 divided by 11 will give you 40. 5225 divided by 11 will give you 475. So you get 475 is equal to 2x plus 150. And then now you make x the subject, you take this to the other side, it will be 475 minus 150 is equal to 2x. 475 minus 150 is 325. Get 325 is equal to 2x. You divide by 2, you divide by 2. So x here will be divided by 2. You get 162.5. 162.5. And because this x represents horizontal change, so it is 162.5 seconds. So this one here is 162.5 seconds. And now to get the, because you're told the time, calculate the time the lorry takes to travel the first half of the journey. So what we are doing is that we are calculating this time here. And we know that this is 150, from here to here is 150, plus x, which is 162.5. So 150 plus 162.5 will give us, so this one here will give us 312.5 seconds. 312.5 seconds. So that is how we get the distance the lorry traveled during the first half of the journey. So that is the end of our lesson today. I believe I've made you to understand something that you may not have understood. Okay? So remember to subscribe my channel so that you'll continue to be updated with whatever that I post. Thank you.